Okay, so all right. So if there are any questions, right, it's best if we can wait. I'm not sure how much it's all going to take, right? But I think it's going to be about the hour. I definitely will have some questions to you. So let's start. So this is more or less the agenda I want to cover. Some topics I'll go deeper than the others, but these are the key kind of items I'll be focusing on. And starting with non-containers and Kubernetes exploits, I'll just briefly touch on it, but on the rest, I'll try and keep on a bit more. Non-containers and Kubernetes exploits, right? So it's quite known, right? Misconfiguration is top concern, right? So there is lots of recorded incidents that are reported on at least attempts for exploitation. So just this is like stats I picked up, from various cloud vendors. Red Hat in their latest said that there was like 53% of detected security misconfigurations just over a year. So that's quite a huge amount of risks, an attack vector, that companies are exposed to. So containers are still at best at what they do, right? Is for packaging and deployment purposes, right? It doesn't mean that they, are secured, right? The boundaries is the security, really. The usefulness of containers is in the software development lifecycle, but the security itself, that's not really attached to the name container, right? The container is more for the supply chain context or for more of the CI/CD context, rather than containing threats or isolating in any level. So that's something that sometimes is kind of a misconception that by the name of it, right, people thinking that it's containing something, but it's really not, right? It's more about the concept of a container that fits in as the previous, like in a doc, and that it can be used as a standard measure between one thing to another. And in our case, between platforms, between various tools, when you want to release your software. So recent vulnerabilities of 22, it's just several names of them: Dirty Py, container, CVEs, kernel levels, that there are quite a lot of them, right? This is just a few of them. Those that were exported, right, so exploited, right, so there is, one of them is known, right, for Siloscape, Team TNT, where the meaning of either container escape or Azure escape, which was not exploited yet, right, but it basically potentially could be through a container escape and Azure escape, right, a hacker can jump between companies, right? So if he was able to escape a container, go to the root, then breach the cluster, then escape the cluster, and then move to another company logic, right, and steal things and propagate. So that was proven by Palo Alto, right? I think by now it's patched, right? But then it's lucky it's a managed service, so because it was in Azure. But overall, Kubernetes non-managed or hosted has version, and each version is having its own issues. So it's important to keep patched and to be aware of it. Some of the container security best practices, right, is to use official and verified Docker image. I'll go through them. Maybe not through all of them, right, but I'll just start with some of them, right, just to give an example. So using official and verified Docker images as a base image, right? So there are verified images today on Docker Hub that when you log in, right, the past, when you log into Docker Hub, you'll get just a list of a zoo. Today, there is a bit more structure, and you get, first of all, the certified ones and the clean ones. And that's the one that you should preferably want to use, right? The official from the vendor, because it also will have a score of security, vulnerabilities that is clean from vulnerabilities. So it's always patched to the latest. So vendor certified is the best image to use. So when you do use it, right, there are still risks associated with it. One of them is really around tagging. So not using tagging, always go for the latest, or when you're using latest, there is risk with that. Why? Because if you are in a security practitioner, like, you need to have a certain control about what exactly the latest version contains, right? So you know that, let's say you certified an image and you know it's a certain version of it, right? And if there is a newer version and developer used another library that wasn't certified or clean or patched, then the service will pick up the latest. And then if it wasn't properly handled or patched securely, certified, right, then you're exposing yourself to vulnerability. So always, make sure that to use the tagged version, right, the fixated version. The next one is using small sized official images, right? So many images are based on different distributions, and sometimes these distributions, even though they're certified and verified, right, they coming with a lot, right? There is quite a lot of services that are not required. So large image is large attack surface. So it's recommended to use, there is a concept called Slim, right? When you're going to Docker Hub, right, there is a Slim version of things, right, where it's focusing on the leanest distribution there. Normally, it's going to be an Alpine wine, but that's the recommendation, right? So if you don't need specific utils, and it's always go for this for the leaner version. The next one is optimizing caching, right? So Docker comes with cache, right? So why is it using cache? Because during build time or with pull time, right, it's faster, right, if the layers are already cached and ready to go. So basically each layer, right, each command that you have in Docker creates a layer there, right? So that's basically how it's structured. So you, if you're looking on the base image, right, so whatever is coming with the Docker by itself, like by the base image, already comes with certain layers. And when you're adding your commands right into the Docker file, it introduces additional layers into it. And overall, the best practice, right, is keep the whatever updates you want to do, right, to the latest possible, to the last possible layer. Mainly because if you're introducing one file change, for example, then and you have a copy command, right, then you pulling from the cache, right, everything that is above it. But if you're introducing it at a certain level, right, then everything else, right, would be not pulled from cache, right? So you basically forcing the images to rebuild. So this is just a small practice, right? So it's obviously it's recommended to optimize things based on that. The other things that I would say, right, is using Docker ignore file, right? So you can specify, right, if you have a certain dependency chain that you don't want to pull, you can always, use Docker ignore file to avoid them. And making use of multi-stage builds, right? That's also always recommended. So you don't have, and you're always in control of what is coming in, and you're always in control of the attack surface that you preferably don't want to expose. And the least privileged user, right? So making sure that you don't, allow any root, and or I would say the unprivileged is the preferred. Like, so either you specify user or unprivileged is the best way to go about it. And the last one is really to continuously scan for vulnerabilities, because there is always new ones that are known or not known or not patch available, but you still can mitigate them. So it's always a good practice to keep on and scanning repeatedly and employ any means and measures you have in order to control the CI chain from letting the image to continue into the registry and so forth. Any questions so far? Sorry, I'm moving to. Okay, so next one is really about I'm kind of I think OWASP is always I think it's a non-profit, right? It's been formed for sharing best practices and around security, right? So one of the things that they're covering, right, is what we published recently is the top 10 Kubernetes security best practices. The first one is really around insecure workload configuration. So it's basically as you can see here, right? The application process should not run as root, and that you always need to have kind of a read-only as a measurement for your file system. You preferably don't want to have a case where you're allowing an image to share the host PID or the CPU or the network, right? Because if something bad happens, right, at least it contained at the pod level, and you can avoid the spread, right, or the breach. So running, the process inside of the container as the root user is a really common misconfiguration in many clusters. So, but you still may want to use root, right? But you need to make sure that, for example, if you do using root, that pod or cluster, at least don't have, internet access, right? Create measures or have some access list. Make sure that it's really doing it in a very kind of last resort, right? And so so there will not be any risk of any other actions that can start a malicious process, right? So confine that, right? And the read-only file system, right? It's mainly in order to limit the impact of compromised container on a file system when possible. So this prevents malicious process from writing back, right? So if it's something already by some sheer acts, you don't know what till the last minute, right? If you have a 0 day, that could always potentially be a threat, and then at least you contain it by not allowing to write anything. So that's just mention just some of the measures that could be taken here. Then supply chain vulnerabilities. So in this case, right, this is the there was a typo squatting, right, attack by changing one letter, right, of an image, and the image that was pulled, right, was a breached image, right? So that's so it's always important to have an integrity, right, on and validate each phase, right? There is like I recommend looking at in Toto.io, right? There is quite a lot of best practices around it, and once you have your team, you can impose, right, at the stations with Toto.io, predominantly introducing it's like a structured way of introducing test cases, right, to validate against the policy, right, if it all matches up and secured. And then so lots of things. I think by now everyone understood and aware of the software bill of materials and its importance, right? You need to know all the time your inventory. Best and basic thing in any security practice is inventory. Whatever you don't see is a risk, right? So inventory, the software bill of materials is really critical. And the next one, right, is the image signing, right? So there's quite a lot of open source tools, right? Some of them, one of them is a CoSign project that is aimed to verify container images. And then the composition, right? I mentioned using minimum slim images with the list of dependencies is the best practice. Obviously scanning for vulnerabilities as previously mentioned. But the next one is the RBAC, right? So because there is quite a lot of teams or feature teams, dev teams that could be involved in developing applications, and each and every one of them might require different type of privileges and permissions and services that requires an access, right? It's easy to get and have a loose, I guess, RBAC configuration. Sometimes it could be a drift because that loose configuration was in staging, and now somebody forgot to change a tag, right? And that is already going into production. So, so the basic things is like really reducing direct cluster access, and don't use service accounts tokens outside the cluster, and avoid any automatically mounting of the default service account token. So there's the overall I guess audit, right, is really also very important because it should include all the third-party components and every action, right? So if something been provisioned, right, at least you have the audit part, how to and what happened, right? And deploying centralized policies to detect and block risky RBAC permissions. So I'll talk about it later in more length. Yeah, when you go into Kubernetes IO, right, there is quite a lot of good best practices there. So there is, I guess, a very significant branch about security best practices that I think it's important to understand and to know. It does have lots of instructive information. There is lots of ready-made examples that you can copy and introduce in terms of RBAC policies. Okay, so as I mentioned, right, policies, right? So making sure that the misconfigured, objects can be blocked using admission control. So Kubernetes has a concept of admission, right? So it means there is a service, so there's an API that you can call and ask whether something is allowed or not, or have a structure that verifies it. So having that structure of policy defined, right, and disallowing images from, like, for example, untrusted registries, it will help, like, to prevent rogue images from running in a certain clusters. So it is recommended to distribute the blocking admission controls policy that explicitly allows images from specific registries or or repos, right? So OPA gatekeeper can be used as a help here, right? I'll talk about it a bit in length, but overall, there's quite good tools like Gatekeeper, Kivano, Kubewarden, right? These are all policy enforcement capabilities that you can define and use and prevent if you're using like a hosted Kubernetes. The next one is inadequate logging and monitoring. So there is a native logging and monitoring capabilities in Kubernetes, so you should be enabling them. One of them called audit logs. So, and basically you can record actions that were taken that will help you with history and backtrack what happened. and events that can indicate any resource state changes and errors. And there's the applications, right, that you developed and whatever containers you're going to lose, so you can define to enable logs there. The cloud provider, if you're using the managed services, make sure the logs are turned on, and it's always a good practice to monitor those and have as well a workflow that attached to those logs. So there are quite a lot of useful tools that can help in monitoring the logs and then responding to them as well automatically. And network logs, right? So definitely Kubernetes has its own network structure, right? So it's important that we always enable those logs around network policies. Okay. So next one is broken authentication, right? So one thing is the human authentication, right? So people need to interact with the clusters for various reasons. So developers, they need to debug, right? Whatever application that runs in staging, platform engineers that building and testing new infra, right? There are various use cases. So there are several methods available to authenticate a cluster, such as human, right? So there's like OpenID, and the certificates, Cloud IAM, and service account tokens. So some of these offer much more robust security than others. It's always good to have some of them implemented, right? So service account authentication, can be presented to the API as an authentication mechanism when configuring with RBAC appropriately. And the other is, avoiding using, certificates for end user authentication, right? So certificates are definitely convenient to use for authentication, but should be used with extreme caution. So the API has no way to revoke certificates, right? So making kind of a scramble, rekey the cluster, it's it's very easy to compromise, and it could leak to a private key material. So certificates are quite cumbersome, so to configure, sign, and distribute. So you kind of use them just as an emergency, as a breaking glass authentication. And the other one is like, don't roll your own authentication like crypto. So you should not build something that is not necessary. Use what is supported by the API and widely adopted. And MFA is always great to have if necessary to access and authenticate. I mentioned before, like, don't use service account tokens from outside the cluster. So always use the tokens from inside the cluster. So Kubernetes service account tokens are obtained directly using the token request API. And they are also mounted into pods, all the pods they're using project volume. All right, the next one is missing network segmentation control. So we all are aware of the concept of zero trust, and then having a mesh type of ISTO project, right? So it's always good to have a way of having a native control, like a multi-cluster. So one way to truly enforce network isolation is to utilize separate clusters when appropriate. So this adds a complexity, but when working tightly with coupled microservices, but it's a viable option when separating different tenants based on this risk. Then the other one is, the native controls, the network policies. So that they are built into Kubernetes itself, right? As I mentioned before, right? There is quite a lot of best practices mentioned around it, and you should as well employ like the WAFA and other controls that could control like how pod communicates, right? So without network policies defined, a proper one, like any pod can talk to any other pod. So network policies should be defined to limit pod communication to only defined assets while denying everything else, right? So that is not configured, right? So access list and so forth, right? It's always a good example. Service mesh, right? So that I mentioned before, like ISTO, linker, HashiCorp console, like there is quite a lot of good examples. So creating a mesh, it's a really good best practice to keep a segmentation, right, for the network traffic within the cluster. You know, CNI plugins, so container network interface, right? The CNI is an open source specification, and it's used to configure access to network resources. So it's a software-defined mechanism for allowing or disallowing network access within the Kubernetes. And it has a wide variety of supported plugins. So solutions such as Project Calico, Cilium, quite a lot of different offers in the CNCF list of security tools. Secret management. So there's here an example, right, of, I don't know if you can see it, right, but basically there is quite a lot of information of username and password that are stored as a clear text file, right? So it's in Kubernetes secret, it's a small object and that contains sensitive data. So it's like could be a password, could be a token. So it's necessary to kind of validate how such sensitive data and credentials and keys are stored and accessed, right? So if you potentially using some source repository, then make sure that you have everything encrypted and everything is properly protected. The other one is encrypt secrets at rest, right? So the etcd component in Kubernetes, right? This database in general contains information accessible via the API. So that may grant an attacker a significant visibility to the state of your cluster. So always make sure to encrypt everything using well-reviewed backup and encryption solution, and considering to use full disk encryption where possible. And then always make sure you cover security misconfiguration, and ensure you have logging and auditing in place. That's also I mentioned before. That's yeah, sorry, I just can see here, right? So enable encryption at rest.
Coffee.
Okay. Then so misconfigured cluster components. So each component, right, has its own configuration risks, and CIS is a great standard, right, that you should go and look and follow. It will list for each and every component of the Kubernetes its appropriate configuration risks, and there are quite a lot of solutions that sorry, there are quite a lot of solutions that supposed to help you, right, with configuration scanning. If you're using the managed one, right, you have, if you're in Azure, you have the Cloud Defender, in AWS Security Hub, Google Security Center, those have a built-in configuration scanners. If you're using third party, right, so Pravasio-like and others, you have an open source, quite a lot of Cloudsploit. There is quite a lot of good examples in the open source that you can use and employ for configuration scan. It's always important to make sure that you make use of it and fix them. So especially the critical ones. And then there is the risk of outdated, right? So if you, when you're using Kubernetes, right, there is not a heaps, but there is enough vulnerabilities and known components, I guess, weak points, right? So you should understand and know that they exist, and it's important to get yourself educated on these and updating them, right? If you're using a hosted Kubernetes, for example, it's not pleasant to update, but it's important practice, right? Because when you have quite a significant or large fabric or workloads, what happens is every time you update, right, it takes a lot of time and then you don't have control of it, but it's important to introduce it and keep up, right? People sometimes are trying to avoid and pushing it to the last minute. Don't do it. As soon as there is some new version of Kubernetes, best practice is start working on your test account or test environment, isolation, update, upgrade, make it a priority for your dev team. Build time security, right? So these are the best practices I mentioned. I'll just have some water. Image scanning, we mentioned, right? Host operating system hardening. So your container or your pod, if it's or whatever, if it's managed and it's hosted, the host has its own security issues. Make sure you harden them and minimize the attack surface, right? Unnecessary components. You wouldn't believe how many unnecessary dependencies teams are pulling in, not because they want to, it's because they are forced, right? There is a way to filter those out, and don't get lazy. Make sure you do the homework, right? And then the other is deploy time security. So we mentioned, so there is things you're doing in the CI, right? Things you're doing at the code level that you can harden things out. And then there's things that you can do during deployment and at the infrastructure level. So there's things you can do at the security groups and firewalls. So that's at the infrastructure level and the configuration. Then there is the runtime security. So network security control. So critical concern is security, in corporate networks, right? Especially, right, is security groups managed by cloud providers. So they are all focused on the node level. So you can control traffic to and from a node, but existing controls do not know which pod or service is running on a node. So this makes security controls largely ineffective at runtime. So because different services may be running on the same node, but at different time intervals. So each with its own security requirements. So Kubernetes by itself, and its workloads are very dynamic and automated. So it's important to make sure that you're aware of everything and you employ everything. And early on in CI, make sure that you validate your, if you have used before deployment and provisioning Terraforms or whatever files, right? Make sure you scan them and find out any risk with network configuration or other configuration, right? Like non-encryption of services and pods and so forth. Anything, guys, any questions? Before I move to the next one. Okay. So these are just, I wanted to kind of show you, right? These are known today risks around Kubernetes, right? As you can see, there isn't a single component, right, in the Kubernetes architecture that don't have a known risk or CVE associated with it. So it's important that you make, you're aware of it and that it's all kind of as insecure as possible. Like that's how you should always look at it and look at things. I wanted to show something, right? I'm not sure if you guys are aware of, there's a public service. I'm not sure if it's a service, right? But there's something called Showdown, right? If you, for example, showdown, right? It's kind of a gray application in the I guess it's been used by for many purposes, right? But just showing you an example that I've kind of scanned for exposed publicly today, right? Kubernetes APIs, right? For the management port of 10.2050, right? So this is like an example, like there's like overly exposed ports, like just I use the US, right? But probably globally it's much more. And I kind of just to show you, right? This is just with how many out there, like with expired SSL certificate, right? That's quite a lot, right? And that's only with overall, like with org domain, right? So you should always make sure that like your things are like, once you use the Kubernetes and it's exposed to the internet, it's quite risky, right? So I'm just kind of picked up just as an example, one IP and scanned, right? I'm sorry. You didn't see any of the. No, I didn't see that. Okay, and here I am talking. Okay, let me. Give me a second. Okay. There you go. All right. So as I mentioned, right, I run a public scan, right, on the US region for looking for any Kubernetes APIs that exposing the management port, right? And it gave me so much of them, right? And then I just picked up something that I know, like that I control, right? And then I ran like a scan, right? So I used a product called, and I'll provide the list, like, so it's an open source tool, Kube Hunter. And I just run a scan. And normally, like what you would also find, right, is anything like once you query the Kubernetes APIs and they're responding to you with a version or with access denied, right? It means like you're already halfway through, because from there to do a brute force attack is not really a big brainer. Like so many tools that out there that will get you in. It's no joke, and normally people don't really caring much about changing default configuration or default password. They might just, an example I can tell you without naming any company, right? Somebody set up a cluster that was with a very weak username and password for the management components. Some hacker, right, just scanned those, brute forced it, found the API. And then from there, he was able to get to a GitHub path. He used and found the project name, the username, and brute force that as well. From the GitHub, he found the secrets of the company, like of some other sensitive, and he was able to copy, right, the entire company source code, right, entire. So these things are very volatile. So make sure you scan your Kubernetes from the outside, right, and make sure that you know that they are not exposed, right. So there is no response, right, of like 403 or access denied or something like that. Otherwise, you unnecessarily putting yourself or your company at risk. So this is, for example, a Cube Hunter. I don't know how much you can see here, right? But it was able to it was able to find for the port, right, that the etcd is open, and then he was able to query the API server of that's the management, like that's it, like it's already something that he shouldn't. And then he was able to find the version, right? Once you have the version, you know already which CVEs that version is, especially if it's not the latest and not patched, right? It's already putting you in control, because as a hacker, through the CVE, you already know what exactly it's open to. So it's really something that I recommend using, at least the open source tools, if you're not using at least the the commercial ones that could be quite expensive. Okay. I'll go back to my presentation mode. So I mentioned Cube Hunter, right? Really recommend to, although it's a competitive product to my company, right? But it's an open source one. It's for free. Use it, right? There is a list. I'll also share my slides as a PDF file, right? And I have like a list of recommended software. But if you go to, for example, CVE details, right, of Kubernetes, right, you would see there's quite a lot of them. And as I mentioned before, to each and every component, right? So this is from the public cvedetails.com, right? This is all known vulnerabilities. And then when you looking inside, like I'm not going to go in and to each of them, right? But overall, there's quite enough of details there to get you started, right? And they're not always a known patch, right? There is not always something that, but there is quite a lot of good and useful steps on how and what to do to prevent and not to get exposed to them. So, for example, even dashboard, although it's one and it's patched, right? But there were quite notorious cluster takeovers just from the dashboard exposed API, right? So as soon as the hacker get and use the dashboard, like there is quite a lot of other things that he can see from there. And it was easy to breach the company, right? Even if it's not maybe from the Kubernetes itself, but from other details that were available in the dashboard. This is a list of Kubernetes scanners. You have so many of them. So Kube Hunter, KubeBench, Chekhov is from Palo Alto. It was from Bridge Crew, right? That will scan your configurations. Kube Audit. So there's quite a lot of good tools. It's very recommended to use and employ each one of them when you need it. For example, Chekhov, I would recommend for scanning configuration at early stage. But overall, there's quite a good selection. I just posted one of them, 8 popular ones, but there's quite a lot of them. Next is so MITRE attack, right? They updated their site with containers related, and most of the things that I mentioned, right, already mentioned here. So I very much I think encourage, right, to look and each and every stage, right, what exactly MITRE has to say and what you should do to mitigate it, right? So we mentioned about default accounts, local accounts, right? That's and not having a root access, right? So there's the items here, right? Is the vehicles, right? To penetrate, to attack, right? So each step here, right? Once you click and you can go through it, right? Explains how an attacker could potentially use and what he can do here, by with what methods, right? So I would really encouraged to go through MITRE and understand the flow here of the path of attacks. But on the same subject, right, if you do use security container tools or Kubernetes tools, make sure you map them, right? So this is, for example, the tool that I used for Kube Hunter, right? The green ones, right, is really the ones that are addressing the MITRE, the previous table, right? Which, so if you tableize, right, MITRE risks, right, and then you use the tools, I recommend as well greening out the boxes, right, that it's actually addressing, right, that can help you. Otherwise, all the other areas, like the gray ones, are not covered, right? So this is just, you know, as an example, right, security that build into your CI/CD, right? That it starts within the unit test, starts at the basic level of the developers and all the way through to the production, right? Each and every stage should be having its own security control. I'll touch a bit on the GitOps subject. I'm not sure if you guys are familiar with it, but are you familiar with GitOps as a topic, as a paradigm? Okay, so GitOps is really it's a new, I guess, culture. Like, so you have DevOps and you have now GitOps, and it's part of what today builds up the mindset of DevSecOps. So what does it mean? It means that you're using Git, right? Like, because once you are in a DevSecOps culture, right, and you're using containers, right, you are the code level, right? As a security practitioner, like, you should be very well tuned and attached to how and what your dev team, feature dev team, how and what they're doing, right? So GitOps basically is a practice, right, that is some software that today that you can use, open source one, to manage the security, right, of your deployment, right, of your infrastructure. I'll kind of some of the best practice, right? So I want to mention that is like when we're looking at security, right, and we're going and using concepts like GitOps, we don't want to come in as dictators, right? We don't want to come in as bosses. Okay, so we want to be part of the team, the dev team, be part of the process, right? So what for example, right, what a boss does in DevSecOps, right? You guys, like, if you can, I just open it to you to tell me, right, what's your opinion and what's your experience, right, where within the mindset of DevOps or DevSecOps, and how things were working, right? And then or should we, right, and why we want to avoid being a boss, or a GitOps boss. Anyone wants to share his experience about why do we want to avoid being a GitOps boss within I guess an automated life cycle or of a development for Kubernetes or security program? Okay, so I'm not sure if anybody from the line, right, but yeah. Is there anyone? But anyway, the main reason is that when you limiting, right, a dev, right, they will find a workaround, right? So when you have something that you're enforcing without explanation, right? So if I'm as a dev, will come in the morning and I'll just try and do my stuff and release things and I write the code and I want to put it in test environment or in staging. And then suddenly I cannot do it. And I don't know why. And the explanation that, and I need to open support tickets and I find it very painful over a day or two, probably within the day. As a developer, you can rest assured a creative one will find a way to bypass your security control. So it's very recommended to use very friendly channels, right, to have your dev team to interact with the security team. It could be a Slack channel, it could be Teams, whatever you guys are using, but where you post what controls you have, when you post what, why there are the controls that you're putting in and how to use them. And GitOps is really the concept that allows you to do that programmatically, right? That you can put those early warnings about controls in the security, in the software lifecycle. Okay, so question, right? In your opinion, right, where or in your experience, right, and everything like could be, there is no, I guess, hard truth here, right? But where do you think, starting point for container security program should be, assuming that you don't have anyone, like say you're coming to a new company, and and the company is working with containers, and there is just some bits and pieces, but there is nothing concrete as a security plan. What do you think is the best way to go about, right? Where would you start? Dev local? Okay. Anyone else wants to explain? Okay. All right. So why do you think dev local? That's right. Well, yeah. So I think definitely. So this is the right question is, if you have none, right, then you always start with the root, right? Because you need to assume that whatever is running already, it's like you're potentially already in a state that you cannot control, right? You don't know the sprawl, you don't know if there is shadow ITs, you don't know any of that, right? So you definitely want to start there. Companies that already go in the cloud, and right, my recommendation, right, is also to go for cluster, right? So start from the cluster, then go to the CD, then go to CI, then go to dev local, right? But if you're planning to move to the cloud, right, it's easier to start from dev local and then go CI, CD, and then cluster. Mainly because from the reason I mentioned, right? Because if you're already out there in the cloud, it's the cluster itself, right? It's very complicated, and it's hard to go through it, right? So I'm sorry, I confused things out. If you're already in the cloud, start from the cluster, mainly because it's already there and exposed, so you can scan it from outside, Kube Hunter, you can see the APIs, but you don't know, right? So you have to go through all the way to the dev local, and that's where you want to enforce the most controls, right? Because if there is any sprawl, right, then the dev local would be the best way to get things out. So, but to do things immediately, like you should, first of all, protect the company you're coming into by understanding what today they are exposing to the internet. So going back to GitOps, right? So what is GitOps? So GitOps is a dev-friendly operational framework. So an operational framework that uses Git, right, as a single source of truth. And I'm just reading from here that you can as well, but also to refresh from here, right? It's basically you use the infrastructure and application deployments, right, as a source of truth. So, so your code, whatever is in Git, it's the source of truth. And that's the biggest difference, right? Because it focuses on pooling, right? So you're allowing your infrastructure to decide what is required for itself to be secured. Whether in push, right, you force the infrastructure, and that's not always going to work, because then infrastructure could fail by pushing things into it, because it might not, deployment will be corrupted, might not go through, right? Something might, but when there is a pool, right, then you know you working on a file, you control the file that is getting pulled, like the information is getting pulled from, and you always know that the process itself, the infrastructure, the Kubernetes itself, as it's today defined, right, will get the latest settings, will get latest configuration, and you know that it's true to your security state that you defined in your declaration. I'll give some example about it. So, question again. So, what does it mean to be a developer-friendly mindset, right? And when should developers get feedback, for example, in a GitOps operational framework? Very good. If I had extra drinks for you. So yeah, so dev notification, make sure and that's the reason GitOps is really the powerful tool, because it allows you to give developers notification as early as possible on the upcoming changes. So they have the ability to raise exceptions to policies and guardrails, right? So you provide support through interactive channel, and we'll show it. So that's the you know, GitOps really helps you to adopt those DevSecOps mindsets. So GitOps, like it's a practical implementation, right? As I mentioned before, right? So why is it practical? Because once you adopt GitOps approach, right, you avoiding manual changes, right? And you practically relying on the pull process, right, to get automatically all the configuration into the life cycle. So as I mentioned, the pull model versus the push model. And the first one is the declarative configuration, right? So the system state is described declaratively instead of providing series of instructions on how to build infrastructure. So you apply configurations and deploying the application. We declare the end state of what is needed. So declarative configuration is idempotent, right, and can be run it's independent, I'm sorry, and can be run multiple times without any impact to the system consistency. And version control, immutable storage. So since Git is the source of truth, right? So the desired system state is versioned in Git. So as you approach your application development, you approach in the same way the configuration status, the configuration file. So you have multiple Git branches, right? Following the Git best practices can be created to apply changes to different environments. So a pull request PR based approval, right, process can be used, right, along with gated check-ins to ensure that only approved changes are deployed to the environment. And automated delivery. So Git is the single place for operations. Yeah. So these are performed by, you know, what it's like called autonomous agent, right? So GitOps, right? The way that it's done, like the automated pooling, right? There is like a robot or an automated agent, right? That it's called autonomous agent, and it will be the one that will be performing the pooling. And Git commit will result in new deployment, and git revert would roll back changes, right? So that's the same concept would be applied here. And that, sorry. The next one is automated delivery, right? Because as we mentioned, Git is the single source of truth, right? So it's going to be performed by, the software agent. So you prevent drift, right? Basically by allowing Git to be the automated delivery platform. So because it's all automated, used by autonomous agent, it's controlled and there is no drift, right? Because you control the state. And the last one is the closed loop, right? So delivery of approved system state changes is automated. So there is no risk of only the one that you know and who controls. You have the audit record. It's in the closed environment, right? You don't allow any other, unauthorized personnel to make changes. You always have the trusted way of verifying changes as you do with code reviews. You follow the process of Git. So why do GitOps, right? Because it allows developers and DevOps team to version control the infrastructure and ship application faster, right? So we mentioned already the standardized workflow, auditability, consistency. That's all the features that really Git provide by itself, right? And you use the same concepts right here in the deployment approach, right? So I would say GitOps, right, is an extension of DevOps, right? By taking the best practices such as version control, collaboration, right, continuous deployment, and applying these to the environment, right? So that's really what it's all about, right? So that's I think, if you want to think about it, really is really that this allows you the DevOps team, right, to version control the infrastructure and ship faster. So that's the what I mentioned about GitOps advantages for push and pull. So the push model, right, the pros is easy to set up and understand, and it works in most infrastructure. But the cons is that it's not as secure as, from the reason I mentioned before, right? It's not as secure as the pull-based model because you're allowing lots of manual changes to happen, right? And it's really better to do it in a way that you have a control on the changes and it's all automatically rather than manually, right? So it's fast, efficient, tighter. The pull model is fast, efficient, tighter, and it's more secure. Example for a tool, right, that is used and popular in GitOps, right, is Argo CD. So Argo CD is exactly what I mentioned, right? It's a declarative continuous delivery tool for Kubernetes, and it automates deployments of application to the cluster. So it relies on GitOps operational framework. So project repository, application repository, right, are used to by the autonomous agent to deploy into the cluster. Other popular tools are Flux and KubeStack. KubeStack is really extended, as well as on Terraform-based files. So how do you bake all together, right? One of the recommended approaches is use GitOps together with the OPA, right, or open policy agents, right? So I'm not sure how much you're familiar with it, right? But OPA itself has two components called gatekeeper and conf test. One is the conf test is defining the policy, is assessing the policy, and the gatekeeper making sure that everything that goes in, right, is based on that policy, right? So before you deploy, you use the conf test to validate your policies, and then for making sure that nothing get passed right through, right, then use gatekeeper to push things back. So what is, open policy agent? It's a set of rules or guidelines that determine how systems should behave in specific situation. So OPA, right, has a policy that allows users to create, delete resources, and deny policy, right? For example, incoming traffic from a specific IP or containers cannot run as routes or images, all what I mentioned before. I'll have a question like, who used open policies before? And if you did, like, if what kind, right? If you software, I'm just for general knowledge. I'm not if it's something new or I'm just blabbering to myself. Okay. So I recommend to use like open policy, right? Agent is today, at least OPA, right, is a Rego language, and it's using declarative configuration, right, to say what is the state and what should happen if you drift from that state. So open policy agent, right, it's an open source, right, a general purpose, right, an engine that unifies the policy enforcement across the cloud native. So as I mentioned, right, you have your engineer, right, he develops the test file, conf test validates the file. If it passes, it goes to merge, and then the autonomous agent pulls it, and then the gatekeeper validates that the policy is enforced, right? So if, for example, you push something that now not allowing certain port, right, that inside the cluster, right, the gatekeeper will make sure that that port like is no longer allowed to be used. So that's pretty much what it is, right? So it allows you to offer as well fast feedback, right? So you can enforce policy locally in the CI, right, without ever needing to connect to the cluster, right? So you do it at the code level before it actually getting deployed. That's where you become dev friendly, right? Because the dev has the early feedback. An example, right, is the day in life of, I took it from a CNCF latest one, right, that there was a team from New York Times that presented it, but it shows like really dev life is really complex, right? So there is lots of things that it needs to take care of, right? And it's important, right, to have a very friendly mindset, right, to give them the feedback in each and every stage right here, right, when he's doing each and every of these actions, right, from developing, containerization, provisioning, test, deploy, right? So the mindset required, like with respect to governance, and it's difficult to maintain, right, for productivity for sake. So technology changes and evolve, and application developers kind of need to learn more on tools to keep up application and to spend less time developing. So that's why, GitOps and having a DevSecOps team really helps, right, the developer, because it takes away from him quite a lot of the complexities, and having a distributed team, right, for example, right, is quite hard to control, right? So if you have, I would say, like the various local, various regions or local teams that are doing different things and developing different things, it's hard to control them, right? So moving to shared Kubernetes environment, right, is quite hard, but it's recommended. So you create a deployment team or delivery engineering, right, that can own and manage things out, and having the delivery or the feature team that just takes care of the deployment process itself. So it's important to adopt a shared centralized Kubernetes architecture. So developers, they don't need to manage or maintain their own clusters, and routinely infrastructure tasks are handled by dedicated ops, right? And platform teams, which are delivery engineering team, to enable the application development team. So basically, you can do it in various ways. Right? Each cloud vendor has its own best practices how to do it. Right? Normally, you would do it with isolated tenants. So each in the same infrastructure, like each team, for example, will get an isolated tenant space that they could develop and run, right? And that will be an abstraction, right? So it will allow consolidation, and as well, the security would be standardized like across all these teams. I'll go quickly right through this, right? Because I think I'm kind of going, into extra time. So shared infrastructure security considerations, right? You need to have a robust policy, right, to ensure compliance across tenants. You need the developer autonomy, reduced freedom with respect to infrastructure and risk of increased frustration. And you need to have feedback, right? So late feedback decreases productivity and increases time to deployment. And you require clear communication about policies, right? So this is an example, right? You should provide with conf test, right? You need to provide feedback and have a fail as in early stage as possible, as I mentioned before, right? And as well as using the GitOps, right, in the deployment, right, to as well making sure that the gatekeeper helps you out to block things out from going in. So if you define that port 80 is not allowed, then you basically validating it before it's getting deployed. So the focus is making policies that are easy to access. So because the policies are stored in Git, and it's easy for the development to see and get, if he got a warning message or a deny message, it's easy for him to go to Git and then check what exactly that policy was and why it was enforced. I quickly go through some conf test policies, right? So OPA have quite a few of them out of the box. There is quite a good examples online. So the conf test policy is using the warn rules or failure rules. So it providing you a structured data error and giving you the ability to define what rule is what, right? So you can say this is a warning rule set, this is a deny, this is a violation rule set. And based on that, OPA will know if to block or gatekeeper will know if something should be blocked or not. So this is an example, like I'll share, this is like a source of location of quite a lot of out of the box policies. Example, like for violations about storage encryption, it's in the context of AWS, right? That EC2 must have a metadata service in specific version, packages that from a specific source on specific version. So these are all ready-made policies that you can use to harness and use and point out or notify about violations. This is just an example about denying latest tag, right? So that's an example from a conf test, right, policy. You have the container spec, right, where you saying, okay, the image is that's the deployment, right? So you have here image defined as latest, and your Rego policy will basically, that's a deny one that will say that if it's latest, right, provide a message. Well, first of all, deny, and then provide a message that image cannot be tagged latest, right? That's just an example. Or if you want to enforce the environment value, right? So if there is no, for example, a label, only these environments are allowed to be deployed, right? Then you can as well harness that type of a policy. And then this is an example of warn something in dev and fail in stage, right? So if it's dev, right, you basically provide a warning. And if it's staging, right, you deny it, right? So that's just an example of how to use environment variables in OPA. Questions? So, I'm just the last item. Okay, sorry. So skills, for upskilling, right? So one of them is like a DevSecOps culture, and then understand the types of policies, enforcement of policies in CI/CD, and exceptions process to policy. And some basic recommendations, since container security is very much a Linux world, right? It's good to have understanding in Linux, and understanding the container structures, it's an advantage. Understanding the various runtime of the container configuration, public container images versus vendor provided ones, understanding concepts of dev build, scratch images. These are the lean images, right? So you start with the limited and lean distro, and how to sign them and create your gold images that only those are allowed to get pulled. And very important, like if you're using a managed service provider, right? Managed cloud provider, those container services important to understand them and understand the attack surface of each and every one of them, and develop the security cycle from your code to production. I provide that there is like basic learning path, what you should be, I think, in what to do in month one. Like, so if you're coming with basic skills, right, not zero, but you can have a gradual path to be a hero, right? So start with the basics of DevOps culture, Linux, Git, package managers, then go to cloud and infrastructure as service, artifact repo manager, and so forth, right? So there's, I think, control the CI, and then understand deployment, and then understand how to work with the infrastructure as code tools and basic programming, like with Python. And then after month 6, right, you should be as well like on top of configuration managers and monitoring tools that require like more complex configuration, like Prometheus. I also provide some good resources, right, that I would as well provide in the PDF file, and that can be shared after. But there is one of the really good book that I really recommend today to go and download by Andrew Martin about hacking Kubernetes. It really gives a very good insight about how and what the security risks and the meaning and how to tackle them. There is quite a lot of things that I can, I recommend as well on playgrounds, right? So there is quite a lot of playgrounds that you don't need to deploy anything, right? You just use them, you go, and everything is kind of available to you to play with without downloading packages on your own local and so forth, right? So that's it. Acknowledgements to, I took lots of material from KubeCon, latest one, from OWASP, and then NIST, right? I specifically recommend looking on Eve Ben Ezra, right? And the talk she provided about the concept of GitOps. It's really kind of enlightening on the subject. That's it. Thank you.
Drinks, and if you have questions, we can answer them. There was one question online.
Okay, I'm sorry.
From Leo. Leo, I don't know if you want to ask it, or I don't know if you can hear me. It was. But feel free to get something to me.
Okay, I'm happy if yeah, send me questions, anything by email or to Scott, and I'll be happy to answer them then.
Leo asked, how can we ensure that the code written by Terraform?
So I think the Chekhov, it's an open source tool, is really a good start, right? They would have quite a lot of from out of the box validations that they will do. So I would start from there. And in Terraform, right, there's privileges that you can find and secure, network risks, configuration. So those are all best practices to start with. Thank you.
you very much.
No worries.
And